Hi, I'm Dave. This is going to be an interactive presentation, so if you have a laptop, now is the time to bring it out. This is a run through what I'm going to go through today, but the basic gist is that WebRTC is not like an intangible object that it's just, it's all features and spec and whatnot. It's actually very easy to get into. And the first demo, as you can see, is called Show Me the Money. So we've put together this demo called Napchat, which surprisingly has no relation to the popular social app called Snapchat. But if you actually want to experience this now, you can open this link in your iOS Safari beta or tech preview for Safari, or just OS X Chrome or Firefox, whatever your fancy is. I'll leave this up so people can look at the link.
What's the password?
The password is TB Meetup, yes. But if you're on that page, this is what it looks like. So this is just basic media. It captures your camera source on a web page. But with the power of WebRTC, you can actually do cool things like throw filters on top. I mean, these are pretty basic filters, but then you can start getting a little bit more advanced. Some black and white, a little bit of blur, some redrawing of the video. You can also add some pretty cool things like face tracking. And then once it's captured your face, you can do, I mean, pretty much anything. Like, but I mean, this is this is one of the cool things of WebRTC. It exposes a lot of media APIs, and this way you can interact with the media yourself, and it's not really a black box. You can just touch it any way you want. But what else can I do? These are use cases that TokBox today powers. I mean, they're real-life companies that use us to do cool things with WebRTC. This app called House Party, some of you may have heard of it. They do basically social media, and you can interact with your friends in a chat room. The cool thing about House Party is that you can see on the phone on the left, they have about 8 streams on a phone going all at once simultaneously, which is pretty darn cool. It's a lot of media going in and out of that mobile device at one given time. Also keep in mind, this is all real time, which is what makes it great. But this is Minerva, which is basically teleeducation. So education from the comfort of your home using your laptop. The layout for this session is what I call multi-party. If you think of the phone as multi-party, you look at the classroom at the top of the page, all those people are connected in real time to each person, and you can go in and out. So the point of this is that it connects everyone globally, but also in real time and having great quality video. I mean, who doesn't want that in their education? This app is called Babylon Health. It's basically a 101 use case that you can connect to your doctor with high quality video in a HIPAA compliant platform. This way you can talk to your doctor from the comfort of your home. There's no need to wait in line. There's no uncomfortable conversation back and forth. It's behind the anonymity of your phone. There's no need to cough and turn your head. It just makes it so much easier. This gaming platform, I actually use this, which is why I love this slide, but it's called Roll20. It's basically a Dungeons & Dragons tabletop game if you played that. But the ability to add real-time communications to the application is what makes it that much more in-depth. You can play the game, but now you can also play the game and watch people's interactions with you live and not have to just read the chat. You can experience their emotions. Insurance, another one. Instead of waiting for an appraisal agent to come look at your vehicle and figure out how much damage has been caused to you, you just pull out your phone and take a video and either record it or let them watch it live, and they can direct you to look at the damage. This makes it so much easier than emailing them, and then they email you back, and they set up a time, they go to your house, and then you just pull out your phone. It's step one, and that's it. It's only one step. Double robotics. We actually have one of these. This is also a pretty cool piece of machinery, but what it is a telepresence robot that you basically slip an iPad into. And using WebRTC, you can control that and go around your place of work from home, so you can work from home while also working from work. It's actually kind of creepy in action, but.
How much it is?
You can. I think this is an older model. I think Double Robotics is newer models, so I think my information is a little out of date. But if Double Robotics is watching this guy wants one. But volunteering, this is actually also one of my favorite companies that uses WebRTC. It's actually sort of it's a volunteering platform that is, as a sighted person, you can help a blind person in their day-to-day activities. Because, I mean, not everything is touch sensitive. So let's say like cans of soup, they don't really know what soup it is because it's not like people print Braille on the labels. So what you can do is they can open their phone, they're familiar enough with the interface to be able to get to the right app, right? And then they can point it at something and ask someone to sign on, and using real-time communication, interact with them in their day-to-day life to improve their quality of life by telling them, like basically lending them their eyes, which is an amazing application if you think about it. But really, what else can I do? AKA, I was not impressed by your 10 carefully put together slides. First, let me tell you a story. If you haven't seen this, basically in August of 2014, Amazon bought Twitch.tv for about $1 billion, give or take, several million. But Twitch.tv, if you haven't seen it, is a video game streaming website where you can watch other people play video games. And this is basically what Twitch looks like. It's kind of like any sort of TV guide channel you would see. You can watch any stream at any time, depending on the game. This is just the popular game, League of Legends. This is what an individual stream looks like. It's a guy playing a game. You can watch his reactions in real time, what he's clicking, what he's doing, what he's saying, his thought process. And then a while back, this actually social phenomenon happened on Twitch called Twitch Plays Pokemon, which I actually experienced a little bit, and it was actually pretty amazing. What had happened was that someone streamed playing Game Boy, and he played a Pokemon ROM. But what made it cool was that the chat was real time. What you could do was input a command into the chat, and then the emulator would actually process your input and then execute that command in the emulator. So if you go back a couple slides, you see these channels. The top one has 46,000 viewers live. Next one has 20,000 viewers. You get the idea of how many people are looking at these at any given time. Imagine 40,000 people putting in the button of their choice into an emulator. It's pretty cool. I mean, it ends up being a little bit ridiculous because it becomes rule of democracy, and not everything works that well. You can see the Pokemons are named kind of weird things because not everyone plays by the rules. But you actually want to go to this link, or you have your laptop out and phone again. This link can exemplify what I'm talking about. So I'm going to leave this up for a couple seconds. You have to do it on basically WebRTC enabled Safari. So yeah, either the Safari tech preview, if you're on a laptop, you can open Chrome or Firefox and it should just work. If you're brave enough to install it on your personal phone, the new iOS beta will also have it. Okay, and then if you open the app, what you should be seeing is basically this. I'm not pressing anything. This is all you guys. You guys are pressing buttons and together collectively playing Pokemon. And as you can see, it's kind of a shit show, right? Like it's democracy in action. How many times you press is what you get. And someone keeps pressing the help button. Like, stop that. But yeah, I mean, this is real-time communication. I mean, the way that the Twitch Plays Pokemon worked was they had a delay. But this is real time. As soon as you press the button, it basically happens in the game right now. So this is, I mean, a very easy use for real-time communication in a social setting. You can play Pokemon with your friends. Now it's multiplayer, or co-op, I guess. But I'll let you guys play this on your phone. I'm going to go back to the presentation. If you're still on this, you can play while I talk. But what's the difference? Why am I telling you this story involving a really complicated Twitch buyout and Pokemon the game, and some emulator. Twitch.tv offers high-quality video. They broadcast to a stunning amount of endpoints. They support live chat. They have a bunch of integrations. They're a really big company. I mean, $1 billion is what they got offered. They're doing something right. So the point is not that the hackathon project I just made is going to challenge Twitch.tv. That's really not the point. That's like a candle versus like a lighthouse. Like, you're never going to win. But my point is, why I'm telling this story is that imagine if you wanted to build your own video platform. You saw Twitch got paid $1 billion. You're like, I want some of that pie. What do I do? How much do you know about media processing now? That's the real question. How much do you know about live streaming media? This is what it looks like to basically stream to Twitch. When you start out, how do you stream to Twitch is using a desktop app, and it composes the video on your computer and sends it to their server. But everyone basically Googles a guide. Like, I've done this. You Google, how do I stream to Twitch? And they send you a bunch of guides. And it's not exactly easy. This is what the actual program looks like. You have to put in a bunch of settings to encode the media. And to be honest, like, very few percentage of people actually understand what these numbers mean. You kind of Google it. You hope to find someone with a situation that's tried it. And it's kind of black magic. You hope for the best. Because not all of us have doctorates in media encoding, surprisingly. But this is why this is cool, because Twitch Plays Pokemon is the indicator that despite the really great user experience they had streaming video and watching people play games, what people wanted was that you could do this in a social setting, that everyone could do this simultaneously, and real-time communication just makes it so much easier. Instead of waiting XYZ seconds, you put a command in, you watch something happen in real life, and it's instant gratification. Twitch Plays Pokemon is basically an example of why spontaneous user experiences with real-time communication in a multi-party setting is a triple win. I mean, why would you not want this? I see this guy taking a photo, so I'm gonna pause for him because I want you to take a screenshot of this. But this is basically all done for you. If you think about this, I put together the hackathon project really quickly, and I can actually show you realistically how much effort it took. But if you think about it, you don't really have to touch all those media encoding settings. The slide I showed you earlier, where it's all these arcane values, WebRTC takes care of all of this for you. And this is what WebRTC gets you for free once you use WebRTC. You get this entire thing in your browser, but you never have to program any of this. This is just given to you. It's already in your browser, actually. And with Safari, now it's in most of your browsers, not all of them. You get this voice engine that does, it has codec support. It does some processing for your voice for error cancellation. There's an echo canceller, and there's a jitter, and I think a packet loss reduction. So it conceals a lot of that, and you just get a good user experience without having to worry about any of this. The video engine has a jitter buffer. There's some image enhancements. I mean, it somehow processes the bits, puts them together, and throws them into the internet, and somehow you get video out of it. It's pretty much magic. But the point is, you never have to worry about any of this. It's just in your browser. If you think about it, you had all that complicated settings in Twitch, but in your browser, why wouldn't you use that to create media? Hopefully you're impressed by now. That was the whole point of this section. If you're not, I don't know what to tell you. But why WebRTC has an advantage over this user model? It reuses existing points and assets. If you were one of the people that played the game with me about 5 minutes ago, you didn't have to install anything. You didn't even have to have a special device. You pulled out your phone out of your pocket, you opened the link I gave you, and it just worked. You didn't have to worry about any of this. That's honestly like a really great selling point. Think about this. If you wanted a user-to-user application, nothing kills that desire more than telling them you have to install this specific application to use this. Instead, it just works. Which is why it encourages spontaneous use cases. And with the addition of iOS Safari, now it's extra mobile friendly. Basically, every mobile endpoint is now covered. You can expect widespread adoption on mobile. And also, power is in the hands of the developer. I mean, if you looked at Twitch, you push a video to them, but you don't really know what they do. But if you also remember my Snapchat application, you can do whatever you want with that processing. You can send it in, send it out, send it nowhere, do something with it, turn it red, turn it green. I mean, it's up to you. WebRTC is also a user-centric technology. I mean, this is a lot of buzzwords, but I actually believe in all these. It's lightweight, it's low effort, real-time, spontaneous, multi-party, Open standard. If your apps don't have any of these things, I think you should be asking yourselves, who are you really targeting? This is a peek under the hood. I mean, this is a developer workshop. I expect some of you are interested as to how this black magic works. This is a very basic idea of how the connectivity portion of WebRTC works. There's a user discovery where it discovers two people who want to send or receive media from each other. In cases of strict firewalls, there's even some logic built in to traverse those. And in the cases where that logic fails, there's a relay server to relay media back and forth between people. So it's pretty robust. I mean, again, this is the engine that processes all the media you get. It captures the media for you using APIs that you just in your browser. It does processing, and then it encodes and decodes those bits and just throws them out into wherever you're sending your media to. WebRTC is not just user-centric, but it's also developer-centric technology. It just works. I mean, you as a developer, you focus on building your application and how that improves your user's life. But you let the WebRTC stack just do its thing. It does media well, and you believe in it. I mean, regular updates from the WebRTC group continually improve the standards, so it's always just getting better. It's only going up. The state of the union and how WebRTC ties into Safari. One too many. Why Safari? Why now? Well, basically, Safari was the last holdout. Out of all the browsers, Safari was the only one that really major browser didn't have WebRTC support. And now that they've joined the game, it has increased endpoint interrupt. You can basically expect everything to work. If you guys didn't have to download the tech preview or didn't have to install the iOS beta, I could reasonably expect everyone to pull out their phone and one of my demos would just work. Plus, I mean, the WebRTC industry is supposed to rise. I mean, apparently as much as by 42 billion by 2025, which is, that's a lot of money. I'm gonna let that sink in. It's 42 billion. That's a dollar bill. That's a lot of money. But it's not all fun and games. I mean, WebRTC is great, but there's some caveats here and there that you can work around. There's a couple known issues. The tech preview is just a preview. It's not the end product. There's issues we currently work around. If you think Apple should do something differently, maybe you can suggest it to them. Maybe they'll take your issue under advisement. But currently, they only support H.264, which is not really up to the most endpoints on Android will support VP8, but Safari will only support H.264, which, as you remember from Puneet, his slides kind of explain that this kind of prolongs the codec war. Hopefully, everyone can come to agreement soon. But another issue is right now they don't publish a screen share, but I mean, it's very possible they could finish that in the future. There's some UI permissions issue with autoplay. They don't really allow you to play a video without a user gesture, being a manual user gesture allowing the video to play in your DOM, which also apparently maybe we could talk to them and maybe they'll think about it. But it's just a preview. This is definitely, if you leave in WebRTC now and you think Safari should do something differently, this is the time to bring a tab. But next steps. This is a developer workshop after all. Let's hack. Also, I love this GIF. But right now at TokBox.com/Safari, you can sign up for a free beta API key. And then for no charge for 30 days, you'll use however much traffic you want to test the Safari beta. But live coding, let's try to build a very basic multi-party app that you can use on Safari. I'm going to leave this link up so you can click it if you so choose. Again, this is if you had the tech preview, which actually I forgot to put the link on this slide, but if you Google Safari Tech Preview, it's basically like the first link. So, but if you let's start coding. This is what a basic multi-party app looks like. You include some JavaScript SDK. Maybe you can use a native API too, but at OpenTalk, I'm kind of obligated to use our API. But these are basically TokBox credentials. Let me expand this. The TokBox, those are really just credential strings. You don't really have to worry about them. But the idea is that you have a set of credentials. You want your user to join a session and either send or receive video to other people in the session. What this is doing is it just creates a session from that API key and session ID. So it's a unique identifier. Think of it as like a hotel room everyone gets a key to, and they're just throwing a party in that room. This gets you into the room. You can get that from TokBox.com/accounts if you want to sign up for a new account. Right, again, if right now we just give you a free trial for the Safari beta if you want to join. But the next line connects you to the session. And then after that, it's a session.onStreamCreate is basically an event listener for when you join the session. After that, if you detect a stream that's been created, you handle that stream. The stream handlers look something like this. You subscribe to the stream when it comes in. So if you're in a session, someone publishes a media stream, you want to watch that media stream, you subscribe to it. I mean, it's pretty straightforward. But if you notice when you connect, there's also something called a connect handler. So not only do you listen for streams coming in, but you detect that when you connect, you also want to send one out. So what you do is you create a publisher. I did publish audio false in case a lot of you joins. I didn't want all the mixed audio like bursting out of my laptop and deafening the front row, but it's you can create a publisher and then you just publish that media to a session. This is it. This is the entire application. It's about like 10 lines of JavaScript, and you get media, you subscribe to it, you can publish your own media to the session. But if you don't want to code at home, there's a link or a deployment we already have called safari.opentalkrtc.com. You can just use this today, and you don't have to sign in or anything. Just use it and experience multi-party video on the new Safari. But any questions?
What's the link?
Safari.opentalkrtc.com. I'll leave it on this page so you guys can look at it. Yeah, sure. My colleague has wisely suggested that I shouldn't use my broken code, but if you want to join, it's, again, so I'm going to name the room Meetup, all lowercase, and then you can just join. All right. Yeah, no, I accidentally opened this in Chrome. Okay, so this is what a working application looks like. So all planned. But yeah, I mean, it's just easy to use. There's nothing to install. You just send people a link, they click it, and then they can send video back and forth. So you can see this is kind of real. This is pretty much real time, I mean. But yeah, that's actually the end of my demonstration. If you take anything away from today, it's that I want you to understand that this is a super tangible product you can go home and spin up and pretty quickly with basically very little effort. But if you guys have any questions, me and my colleagues are here to answer them. Neat's over there. Chris is somewhere around here, I think. I think that one's a little bit hard to answer. Well, the question was for the Pokemon app that we just played, if there's too many streams, what's the magic number at which it's too much and the device just doesn't like it, right? Right. So that also asks the question, what kind of session layout do you have? For the Pokemon game, it was my laptop broadcasting the Pokemon game to you, and then your device never subscribed to more than one stream. So in this use case, it wouldn't matter how many people connected to the session. Each device would only watch one video, and then I would only send one video. So the device wouldn't have an issue. But yeah, in this kind of situation where it's a multi-party stream, a lot of that also matters between how much video they're sending you. Like if they're sending you really low quality video, you can, like logically, I think probably subscribe to a little bit, a couple more streams than you would have to subscribe to if you only had a couple really high quality videos and they had to render a lot more pixels. I mean, a lot of this is just, it's like guesswork, but it logically makes sense, right? So there's no real magic number I can tell you besides what you try in your device. I mean, it also matters like how many apps you have open, that kind of thing. I know it's kind of a lame answer, but.
Also your bandwidth, right?
Yeah, also your network bandwidth at the time. You're connected to Wi-Fi, you're connected to your 4G network, 3G network.
Is this going back to a server, or is this all peer-to-peer or peer-to-peer?
That's a good question. The question was, is this all going to a server or is this peer-to-peer? That's actually something you can choose. Usually it's peer-to-peer, but the value TokBox provides is that we do the media routed through a server. So the normal peer-to-peer model for there's 3 people in here, right? So let's say this guy sends video and he subscribes to everyone else. He has to send one video stream to the one in the middle and the one on the right, and then he has to receive a video stream from the one in the middle and one on the right. So that's 4 total connections this person has to maintain. The TokBox model that's going through a server instead of P2P mesh is that person would have to only send one out and receive 2. Obviously, that's only a gain of not having to manage one stream, but if you think about a model where it becomes 8 people in a session, it's like an exponential growth rate. It's a lot less managing of the streams.
And that's all WebRTC that makes that decision, or is that how you guys set it up?
The P2P stuff is all WebRTC based. The server routing, where it's intelligently only sending one stream up and then subscribing to one stream down from each one, that's something we do.
Can you select bandwidth on these?
The bandwidth is not.
Repeat the question to guys.
They wanted to know, can you select the bandwidth? Through TokBox, no, but I believe through the native WebRTC, you can do a little bit of wizardry to change the set bandwidth. But typically, I mean, I really wouldn't do that. The WebRTC engine has a bandwidth estimation algorithm that's pretty good. I mean, it figures out how much realistic bandwidth you have and doesn't try to publish more or less than that. It tries to use as much as it can up to a certain point, and then it just adapts to your situation based on things like packet loss and how much bits get received and sent. Does that answer your question?